Hello. In this episode, we are going to discuss about the MVC layers. So these are the layers, model, view and controller. And in this episode, I'm going to discuss only about the model. So let's see what are here in this model folder. First, we have models and then services, storage provider, networking provider, helpers, etc. So what is the model? Let's have a look. We have Pokemon list model and Pokemon list. This is the from this Pokemon list model we get the result type, and from that result we got Pokemon list. In this list we have name and URL. Here we are populating the table view from the Pokemon list, the name. We are only populating the name, and when we will click any of this cell we will take the URL and pass it to the next page. Here we have Pokemon detail model. Let's fold this code right now. Let's focus only on this now. So we have Pokemon detail model and we have a JSON object sprite model. Sprite model only contains a from default string. And we have a model entity map protocol, and we have two functions here, map to entity and map from entity. What it does, map to entity, it maps the model data to core data entity, and map from entity, it converts the core data entity to data model. So let's have a look. Here in the Pokemon detail model, we are using this. We are using an extension to implement this protocol. Here map to entity, it is mapping this core data model to data model to core data entity, and here map from entity, it is mapping core data entity to this data model. So let's have a look what we have got in the core data entity. So if you go to Pokemon data model, you will see Pokemon detail and sprite entity. I kept it similar to this Pokemon detail model and sprite, and this is the file it represents this data and sprite model, and in the core data this is similar, and the variables are also similar, height, name, weight. And if you see here, height, name, weight, sprite is a JSON object. Here we have a sprite as a relation, and if you see the relation, this is 1-to-1, but take a note, the delete rule is cascade. What cascade does is, if we delete a Pokemon detail, it will delete the related sprite as well. But in the sprite, if you see the delete rule, this is nullify. So if you delete any sprite, it will not delete the Pokemon detail. So it's like higher module, it's not depending on a lower module. So here sprite is lower module. If you delete it, it will not delete the higher module. But if you delete the higher module, which is Pokemon detail, it will delete the lower module. So that's what the cascade delete rule does. So these are the data model and mapping function, mapping protocol. Next we have services. So we have some API service and some storage service. The API service, these are service for implementing data from the internet, fetching data from the internet, and the storage service, these are responsible for fetching data from core data. So let's have a look what we have in the Home API service. Home API service fetches data with the help of a network provider. So let's have a look what we have in the network provider. Network provider is a protocol, and in the protocol we have only one function, is load. It will load data with a URL request, and it will publish data. Any publisher, it's any publisher, and it will publish anything with the data or an error. The load function, it loads data with the help of URL session, data task publisher. It will only fetch the data and map the data and publish the data. So it's task only to get the data. I've given it a name load. It can be get, any other networking related task like post, delete, put, whatever, it could be here, and we can replace the URL session with Almofire or Moya, anything, only in this file, and it will not affect any other file. So this is the advantages of using a interface like this and implementing like this. So we are using this networking provider to load data, and here the home API service, it decides what to load or what to get from the internet. But how to load, this is the task of a network provider. So it says that to load Pokemon list, so it will load the Pokemon list and get a result of type Pokemon list model, which we have seen here, Pokemon list model. So this is what the API service does, fetch the data with the help of a network provider, and we are injecting the network provider in the initializer. So this helps us to test it better. We can make a fake network provider and we can inject that fake provider here in the initializer, and it will help us to test it better. The detail API service, this is exactly same. If you have a look at the code, you will understand. I'm not going to detail it much detail, but the home API service is responsible for the homepage networking activity, and the detail API service, and this is responsible for detail page API service, detail fetching data for the detail page. But we have another service for the detail page, which is detail storage service. If you see in the detail page, we have a hard button, and this is hard empty, but if we click it, it is hard filled, and now it will store the data in the core data. So that's why we have a networking service, also a storage provider service. So let's have a look what is the detail storage service does. In the detail storage service, we have two functions. It checks if the data is favorite, and we have another function, save or delete. So whenever we come into the detail page, it checks whether if it is in the favorite list or not. Also, when we click on the heart button, if it is not there in the favorite list, it will save it in the favorite list. But if it is in this favorite list, it will delete it from the favorite list. So we have a function like this, save or delete, but it implements the storage services with the storage provider. So let's have a look what we have in the storage provider. In the storage provider, this implements the core data. We have a persistent container, and in the initializer, it initializes the necessary things for the core data. And we have a function to save context. We have a function to get all data. It gets all the data with the ascending order with name. And we have a check if favorite function. It checks if it is in the favorite list in the core data, and it does by a predicate by name. And we have a delete function. It deletes by name. So I have put all the core data related functionality here. I did not put any fetch request or predicate in the storage service. In the storage service, you just call the necessary function. It will do the task accordingly. So here, if we see check favorite, the check if favorite, what it does, it call the storage provider instance and call the function, and we are providing a parameter. It checks with this parameter. So this is what does the detail storage service with the help of a storage provider. And one more thing, like I have to mention, the storage provider, we have two types. One is in memory, another is persisted. And by default, it is persisted. But when we will test the core data, we are going to use in memory storage type. So that's why the storage type is like this. And the manage object model, This is especially for testing, because while testing, every test should create an individual test case, and for testing core data related stuff, there are multiple instances. So to update the performance, we have created this manage object so that only one object is created while testing. So, and all the core data related stuff is implemented in this one single instance of a object, manage object. Also, for storage type, in memory storage type, we have this line of code, and this is because by default the core data uses SQL for under the hood, but in memory it uses your hard disk, the RAM, to do the testing. But so it could be different, like the SQL fetching, deleting, or other important stuff, and fetching, deleting from the memory. Sometimes there could be some difference, but with the help of this line, the in-memory database acts like an SQL, and so that there is no difference between real life scenario and with the test case. So this line of code helps us to achieve that thing. So yeah, these are all the necessary things you need to know about the core data and the functionality. Also, we have a favorite storage service. What it does is get all favorite and delete anything from the favorite, and this is responsible for this page. And if you see, it is getting all the favorites from the core data, and if you want, you can delete any favorite from here. Besides this, we have some helper function. This is the helper function. This is for the navigation color and text color. So, and this is that. And constant, we have a static function, which is base URL, and we are using it here. Cause this is here we are using the constant, and we have some extension. We have an extension of UI view controller. In this extension, we are using the SV progress HUD. The progress HUD is responsible for the loader. Here, you could see the loader, but I did not include the library in each of the individual view controller. I separate it here with an extension. So it follows the rule of dependency inversion principle. So in solid principle, what dependency inversion principle says that higher module should not depend on lower module. So loader library like SV progress HUD, this is considered a lower module, and the higher module is the any kind of view controller. So a view controller should not depend on loading library like this. So I have separated it here like this, and if you change the library, it will not affect any of the view controller. You just need to change in only one single file, and no other file will be affected. Same thing is happening here. The Kingfisher library, this is responsible for the image downloading. So sometimes if the library is deprecated or not managed anymore, or if you want to use any better library, you can just change it here, and rest of the image view will not be affected. So that's how you implement the dependency inversion principle. This is one of the example. So yeah, this is what we have in the model, and in the next episode we will discuss about the view.